Did you know that up to 35 of Generative AI Certified Professional GAICP candidates fail their exam on the first try? Will you be one of them? Not if you prepare the right way. Let's see if you can answer these real questions from our practice tests. Question 1. Your health tech startup is building a triage assistant for clinical notes. You have about 3,000 labeled examples, must provide transparent rationales to auditors, and can deploy only on CPU-based on-prem servers while note patterns drift quarterly. A PM insists that we need AI, which means deep learning, and suggests fine-tuning a large transformer end-to-end. Which response best clarifies the AML-DL distinctions and recommends an approach aligned with these constraints? A. Agree with the PM deep learning is what makes a system AI, so fine-tune a transformer on the 3,000 notes and use post-hoc explainability. CPU deployment can be managed with quantization. B. Rely solely on a rule-based triage system because it is AI without ML, avoids data limitations, and is easiest to explain to auditors. C. Clarify that AI is the broad field, ML is a subset, and DL is a further subset. Recommend a hybrid deterministic rules for critical never-miss cases, plus an interpretable classical ML model, e.g., regularized logistic regression or gradient-boosted trees on engineered features for the rest, deferring deep learning until data, compute, and explainability tooling are adequate. D. Use an unsupervised deep autoencoder over all notes to learn embeddings, then add a small classifier, categorize this as ML but not AI to satisfy auditors' concerns about explainability. What's your answer? Take a moment to think. The correct answer is C. The question tests nuanced understanding of AI umbrella, ML data-driven methods, and DL neural network-based ML, and how to choose among them under real constraints. The correct answer clarifies the taxonomy and proposes a hybrid that meets data, compute, and explainability needs today, while keeping DL as a future option. A common pitfall is equating AI exclusively with deep learning or overcommitting to rules that cannot handle drift and nuance. Question 2. Your team packs multiple independent user prompts into a single long sequence to improve throughput on a decoder-only LLM that uses rotary positional embeddings rope and a standard causal mask. Despite inserting EOS tokens between prompts, you observe completions that copy content from neighboring users' prompts, with attention maps showing heads peeking across segment boundaries near EOS. You cannot retrain the model, but can modify runtime attention and positional handling. Which change is most likely to eliminate the leakage? A. Switch to multi-query attention shared KV across heads to reduce memory pressure, which will stabilize attention and prevent cross-segment interference. B. Enable KV cache reuse across different packed segments so repeated prefixes don't need recomputation, reducing drift that causes leakage. C. Use a block diagonal attention mask that forbids attention across packed segments, and restart row positionids at the start of each segment, segment-aware row P. Increase maximum context length and switch to LAB so long-range attention decays smoothly, reducing spurious spikes near EOS. What's your answer? Take a moment to think. The correct answer is C. This question tests attention masking and positional handling in packed sequence inference with rope. The correct solution is to enforce block diagonal segment-wise attention and reset position indices so no cross-segment attention is possible, and rotary phases align per segment. A common pitfall is assuming EOS tokens, longer contexts, or architecture tweaks, e.g., MQA-ABI will prevent leakage without an explicit segment-aware mask and positional reset. Question 3. You are designing a prompt to classify incoming customer emails at a fintech into 4 labels: outage, billing, phishing, and general. Zero-shot prompting overpredicts outage whenever messages include the word urgent or, and recall for the rare phishing class is poor. The model must return only the label no rationale, and your context window is limited, so you can include at most 8 short exemplars. Which few-shot construction is most likely to improve robustness and label compliance under these constraints? A. Provide 8 outage examples featuring urgent and emojis to firmly teach the outage decision boundary and reduce confusion. B. Include detailed rationales after each example explaining the decision and instruct the model to output both label and rationale, which you will strip in post-processing. C. Curate 68 concise, schema-consistent exemplars that balance all labels, include minimal pairs contrasting messages with without urgent, and specify output label only lead with a canonical example for style. D. Randomly sample 8 diverse logs from different months and vary example formats, some with labels first, others with text first to maximize generalization. What's your answer? Take a moment to think. The correct answer is C. This question tests the practical construction of few-shot prompts coverage, exemplar selection, and schema discipline to combat spurious correlations. Option C is correct because balanced, minimal pair exemplars and a consistent output contract directly address both robustness and compliance under a tight token budget. A common pitfall is assuming more examples, rationales, or random diversity automatically help. When targeted, schema-consistent few shots are superior. Want more questions like these? The full course contains 300 similar scenario-based questions. Why choose our course? Because we provide detailed, scenario-based questions with deep explanations for every single option. Get instant access to 300+ questions and 5 complete practice tests. Start passing today with our 100 success guarantee.